Good morning to all of the students. We will continue the law of motion today. Now, as I already told you in page number 2, you have to do a correction. The distance traveled in a particular direction by an object in unit time is called speed. So they written a velocity. If in your textbook written velocity, just correct it and write speed there. And displacement that occur in a unit time is velocity. Now, first we will see here SI unit. SI unit of the distance is what, and see displacement is what. The unit is both same, meter per second in the case of SI unit. In the case of CGS it is centimeter per second. Speed is related to distance and velocity is related to displacement. Now they are given the same thing if the motion is along a straight line. If the motion along a straight line, the value of the speed and velocity will be same. The motion they are telling it is moving in a straight line. If it is in a straight line, then the speed and velocity will be same. Otherwise it will be a different in the change of the directions. Velocity is the displacement that occur in unit time. Only in a unit time velocity will be occur. Now first see an example. Now we will discuss Seatal speeds along the path A, then along the path B, and then average speed. Just see in the first example of the figure on page number 1, location of the school and houses. Seatal house to Sangeeta house and Sangeeta house to school. So they given the same thing here. Seatal house along the path A. First distance upon time. Seatal house to Sangeeta house distance is 500 meter. If we travel in a 5 minute, then it is 100 meter per minute they given. But Seatal house along path B means they are telling the Seatal is going with Sangeeta to school. That is 1200 meter distance. That is 1200 meters distance, but the time now it is different. It is 24 minute. So it is 15 meter per minute they given. But the average speed means you have to add it. It means 500 plus 12, that is 1700, and 5 minute plus 24 minute, it is 29 minute. Now here the speed is different, that is 58.6 meter per minute. It is a case of the speed. But in the case of velocity, it is displacement. Displacement is what? 1300, and distance was, it is actually 1700, that is 400 meter less, and time will be same. Now in this case time is what? 29 minute. So you will observe the velocity is what? 44.83 meter per minute. Now in the case of the speed and velocity, you will see the difference of the time. In the case of the speed it is 58.6 meter per minute, but in the case of velocity that is 44.83 meter per minute. This is a difference of the velocity and the speeds. Now effect of the speed and direction. What kind of effect will be there if the speed will be changes and if the velocity will be changes? So you given the figure, motorbike is there taking a round. In the case of the car, so here look, Sachin is traveling on a motorbike, they given a. The effect of the velocity on the velocity, if the speed will be increase or decrease. Speed is increase or decrease, but the direction are not changing. Is there any change? Is there, it will be affected, velocity will be affected? Or in case of when the road turn will be there. Now the road turn is there, that is the case of the distance. But here speed is constant. Speed are change. And here the effect on velocity. Velocity will be affected. Third one, if on a turning, on turning time, Sachin, they are telling changing the direction also and the speed also. So is there effect on the velocity? They are asking. So they given on down keys. They given on the down. Look, first when you are changing the speed, you have to keep the direction change, and when you are changing the direction, you have to keep the speed same. Otherwise you have to change the speed also and direction also. This is the three things they given. If you are changing the speed, you have to put the direction same. The direction should be same. And if you are changing the direction, the speed should be same. Okay. Now, but the third case, you have to change the direction also and the speed also. Always remember the given. Just see the block they given, the downward figure, downward paragraph. The first scientist to measure the speed as the distance per time was Galileo. Galileo has measured the distance, the speed of the sound in dry air. He given as a 343.2 meter per second. In a dry air, the speed of sound is 343.2 meter per second. While the speed of light he given as a 3 into 10 raised to 8 meter per second. And the revolution of the earth around the sun, the earth is revolving around the sun is what? 29,770 meter per second. So Galileo told the speed of sound in dry air. So when the dry air will be there, the speed will travel 343.2 meter per second. Means when when air is very less, so your speed of the sound will be travel 343. And the speed of light they given 3 into 10 raised to 8 meter per second. You know very well this is the common thing. But revolution around the sun, revolution around the earth, around the sun. Our earth is revolving around the sun is what? How much speed they given? 29,770 meter per second. Means in a single second, the earth is revolving 29,770 meter. This much of the revolution in a per second. Now, uniform and non-uniform linear motions. Uniform and non-uniform linear motions, this we will learn. Just see they given an example of the distance covered by the Amar, Akbar and Thoni, and they given a time of every half hour. First we will see the distance of the Amar and the time. Time of 5 o'clock, then 5:30, then 6 o'clock, 6:30, 7, 7:30 and 8 o'clock. At a 5 o'clock, the Amar is on the initial position, that is 0. At 5:30, he travel a distance of 20 km. At 6 o'clock, he travel a distance of 40 km. At 7 o'clock, he travel a distance of 80. Like this way, at 8 o'clock, Amar cover a distance of 120 km. But observe, there is a difference of every 20 km. And at 20 km of half hour. Means every half hour, the Amar is covering a 20 km distance. So if on every half hour the Amar is covering the same distance of 20 km. So this we are telling as a uniform linear motions. This we are telling as a uniform linear motions. Means at equal interval of the time, equal distance are there. At equal interval of the time, at equal distance Amar is covering. Means in half hour the Amar is covering 20 km on every half hour. But in the case of the Akbar, first see, at 5 o'clock Akbar was 0 initial position, but at 5:30 Akbar is covering 18 km. At 6 o'clock Akbar is covering 36 km. But at 6:30, now just see the distance, 42 km. Then the given a distance of 7 o'clock 70. Then 7:30 it is what? 9 o'clock 95 km. If you will notice, from 6:30 the times, the kilometer are different, but the time are same. Now it is not initial. The times a kilometer are every time changing at every half hour. It is not stable. It is not stable. But in the case of Amar, you will observe at every half hour the Amar is covering 20 km. But in the case of Akbar, you will notice that from 6 o'clock or from 6:30 or 7 o'clock, 6:30, 7 o'clock, 7:30, the duration, we can say distance are not same. When the distance are not same at every interval of the time, at equal minute of the time, or we can say at every half hour, the distance is not covering a proper kilometer by Akbar. So this we are telling as a non-uniform linear motions. Means at equal interval of the time, the distance are not covering in proper. The distance covered by Akbar is not proper. So this we are telling is a non-uniform linear motions. Means at every half hour the Akbar should cover a equal distance. Means till 6 o'clock Akbar has covered a equal distance. But after 6:30 the distance covered by the Akbar is not same. Now distance covered by Anthony, just look. At 5 o'clock 0 on the stable positions, initial positions, but at 14 5:30 the Akbar Anthony distance covered by Anthony is 14, then 28, 42, 56, 70 and 8 o'clock. Here just look, see the difference of how much difference at every half hour. 14 14 14 kilometer distance. There is a distance covered by Anthony at every half hour is 14 kilometers. So the Akbar distance covered by Anthony is also, we can say, it is coming in a uniform linear motions. Amar and Anthony is in a uniform linear motions, but the case of the Akbar it is non-uniform linear motions. In the case of Anthony it is a uniform linear motion, but in the case of the Akbar we can't say as a uniform linear motion, that we are telling as a non-uniform motions. So these are the examples of the what uniform and non-uniform linear motion. Means at equal interval of the time the distance should cover should be same. At equal interval of the time the distance also same. Now just see, use your brain. If an object cover unequal distance, they given in equal interval time, it is said to be moving. They are telling here the object is, the distance is unequal but the time is same, then we are telling as a non-uniform speed. So we have seen as an example of the uniform and non-uniform linear motion. So Akbar, Amar and Anthony has a uniform speed, but in the case of the Akbar it is non-uniform speed. Here for example, motion of a vehicle being driven through heavy traffic. If the heavy traffic will be there, so it is possible the motion will be there. We can say it is uniform linear motion. Is it possible? The distance will be not same, because every interval of the time the vehicle will be stopped. We will continue tomorrow the next lecture.